So good morning and welcome to the last lecture in this short 3 lectures course. And we will close this discussion on the dimensions of sustainability and sustainability assessment in Nano and Bio projects. So today, at the end of this lecture, you are going to hopefully perceive sustainability from an engineering perspective, and that's how we apply this to different projects, to evaluating, benchmarking, comparing, and improving different engineering processes. I hope that you also understand life cycle assessment as part of a sustainability analysis, not as a sustainability analysis itself. And at the end, I will show to you, and I hope you take this home message, perhaps, because it links with what we have discussed in the previous 3 lectures, is that this value chain approach and a sustainability framework that can help accelerating the development of bioproducts innovations. So to achieve that today, this is basically the title of this lecture. And you're going to see like the dates here are not exactly the same dates that you are having the course as the dates that I'm recording this lecture, so about a month before that you were actually listening to it. And I'm looking forward to meeting you for the discussions after you have listened to these recorded videos. I think it's much better when we can be face-to-face, even if it is me in Finland and you guys, wherever you are around the world. So today we are looking at the technical, economic, and environmental perspective, and I'm going to bring the first lecture. We talked about the technical and risks, and then the second lecture we talked more about the economic and risks, and now we're going to talk about environmental and risks as well, and how do we bring that in the context of sustainability. So we are going to go through some very basics, so we are all on the same page. So what does sustainability means? What is an environmental assessment? And then we can do that through LCAs. And then we're going to discuss then how do we broaden this up? How do we consider the full spectrum of sustainability? And we take this engineer's perspective. So as you have seen this slide every time, every lecture, today we are focusing on this bottom part here, and this feeds both what we have seen before, the technology plan and the business plan. For example, I just brought here one part of the technology plan just to exemplify. You have seen in the previous lecture that we looked at block flow diagram, right? We looked at how do we think about the CapEx and OpEx, economic evaluation. We looked at what is the technology readiness levels. We looked at all the different types of risks that appear in technologies development and how those can actually make things unfeasible at the end of the day or take too much time. And then we looked at what are the potential market requirements for different types of products. And this, to some extent, fits both the business and the technology plan. And now we are looking into how we look at the environmental issues, environmental considerations in the context of nano and bio technologies or projects or proposals or processes that we are developing. And I want you to really keep an open mind today. And the first thing is I want you to stop and think about what does the word sustainability means to you. And I'm literally actually giving you 1 minute or something to think about it. I asked this question to my students I teach thermochemicals processes course here at Alto, and sustainability in bioproducts and developing processes and technical-economic analysis. So I always ask the students, and a lot of the time it comes down to, and of course we are part of the School of Chemical Engineering, so a lot of the time comes back to the perspective of life cycle assessment. So everything goes into that bucket. What is the CO2 impact? Does climate change? Net zero comes. So the sustainability comes a lot about that perspective. Then I always asked my friends, researchers, students from various different backgrounds, what is the application that you are working on? So is the material, the product, the nanomaterial, or whatever that you are working on applicable to a relevant sustainability problem? So what is the sustainability problem that you're tackling? What does that connect? Because when the people say, oh no, I want to fight climate change, but how? How does the application, the work you're developing helps fight climate change? What are the actions that you're taking to make this work? Then I have something ridiculous here, like really, this was made up. This is not true, okay? This is from a TED Talk from Julian Allwood, which is kind of a cool last name, from the Royal Society of London. This is fake, of course, but imagine making a solar-powered sunbed, right? Because we now, like, when people do this, I've never done this, but in the sunbathing thing, use a lot of energy. So here we use solar-powered energy to heat, to provide electricity or energy to the sunbed. And the funny thing is, like, absurd, ridiculously expensive. It's made to look funny, and that you at least feel green while you're getting a tan, while you're getting your body a nice color. And this is completely fake, but it's just to say that out there are actually, unfortunately, things in the grocery stores that are actually much worse footprint economically and in many ways ridiculous. So I want you to watch a video with me, and that video is an Audi marketing advertising that was released in 2010 and during the Super Bowl. So Super Bowl is basically, the final of the, I don't know, in Brazil would be whatever, Campeonato Brasileiro, or I don't know. For me, Gaúcha is a Gauchão, but for maybe perhaps for you guys it might be some other local, but it's the biggest and the most expensive advertising screen time is during the break time of the Super Bowl in the US. So Audi put that advertising there in 2010, and there was a lot of discussion about it. I wanted you to watch it, and draw our own conclusions on how advertising and how we can think about environmental actions in different ways and even funny ways. So I guess I'm going to stop share, and I'm going to share another page with you. I want you to watch with me. Okay. And then I'm going to share that screen. Share, and I believe you can see this. And if you don't, you're not able to listen to it well, then maybe you can take the link, copy the link from the slide, and try to watch it during the time. Or maybe the organizers can copy and paste the link into the chat. Or if I'm there at that time, I'm gonna do that if this doesn't work. But I want to. So hopefully you were able to hear it and to see it. And now you can see my bigger screen, hopefully. So so basically this it still is actually 13 years ago or 12 years ago, and it's still being discussed as, you know, how we perceive. I just want to see what you're seeing. Okay, you're seeing the right screen. How we perceive sustainability and in our daily lives, and how they were making fun of this almost like Nazi green police, and that, you know, you're using biodiesel, so you're good to go, even though you perhaps were buying a very expensive car that 99% of the people cannot afford, and that the actually savings from this full value chain of making the car and using the biodiesel to run that car, it was actually worse than some regular, commercially available medium cost, average cost cars. So, you know, you can draw your own conclusions. That the advertising is quite fast, and maybe for language purposes is too fast. But if you have the time, I really encourage you to watch it again slowly and pause, and then it's kind of funny. But it's to some extent, it's also like making fun of you know, how we should be behaving, how we are behaving, and making fun of sustainability in a sense. But I will leave you to have your own thoughts, your own considerations about that video. But really keep in mind what you're doing, is it you're doing relevant. I'm not saying that making biodiesel, it's not relevant, it's very relevant. It's just that being accessible to lots of people is also relevant. Why is that? Because what is sustainability if we want to really consider the overall sustainability? And now I want you to think about what you thought before when I asked what sustainability means to you. And we have been talking about in the previous lectures a lot about this techno-economic side of things. And this is sustainability. It has to be feasible. We need to be able to make it. We need to be able to sell it. We need to be able to make it reach the large masses. Because if only a few people can afford it, then, you know, the difference you're making, it's so small that is not really going to affect the overall climate change issues, the overall net zero targets that we have. So in the social side of things, what is the impact to the rest of people? When you close a mill, you open a mill in somewhere else, when you are disrupting a value chain, when you're moving the whole textile production to Europe and out of developing countries like Brazil and Asia, and India, no other countries in Asia. So, and then it's also about environmentally centric concerns. It's also about the use of natural resources, the ecological capacity, the boundaries that we have, how much are we harvesting, how much the forest growth, how much are we affecting the biodiversity of soils, of forests, of the overall ecosystem. So, and how much are we emitting, how much are we sequestrating, you know, this whole balance of the environmental life cycle related type of things. So it's really about at least these three things, and sustainability is in the middle. So we shouldn't look at it only from one lens. Or we put the sustainability lenses, we see where it makes sense for us, and then we take it up, and then we go about our business, and then we forget about it, and we just choose one of the three that makes more sense for our projects. And we really need to be holistic on how we look at sustainability. Another thing that's very important, for at least for myself and my students that are engineers, and for society overall, is that we need to deal with constraints. And if you're like me, that like modeling, when you're modeling, you are all about you maximize, you minimize your objective functions, and then you have constraints, and those constraints are about the amount of, I don't know, chemicals you can use, the amount of raw materials available. So you find, I don't know, the maximum capacity, the minimum transportation cost. It's all about constraints. And that's what sustainability is. We need to live within constraints, and we need to develop solutions that respect those constraints so that we can grow as a society. So this is a lot of reflection stuff, but it's important that we reflect before we act. So if we think about that we need to grow as a society, and this is why we have this called Sustainable Development Goals, that everybody at some point is asked, either the industry, now professors, for instance, my profile within Alto, that's one of the first things that I need to answer is, where does my project fit the Sustainable Development Goals? So it involves multiple disciplines, it's multidisciplinary. Sustainability is not just about one little part. It is about society, it is about technology, it is about the whole ecological world that we live in. So how are we working towards helping ensuring sustainability on planet Earth? And this is what the Sustainable Development Goals are about. So you look, have you tried ever look at them into the detail? So you open them and then you look at the sub objectives, and then you look at examples. Actually, if you look deeper, you're going to see that there are so many things that I at least haven't thought about. Nonetheless, we need solutions to achieve those sub-objectives. We need engineering solutions. We need to be able to find these constraints, to model these constraints, to understand where does we find that sweet spot in the middle, that triangle that means sustainability, that we can cover the environmental, the social, and the economic perspectives, techno-economic perspectives, so that we ensure continuity. Is about we need stuff. We need materials, we need products. So how do we make these products? How do we maintain the needs of society in a way that balances with what we take from what we make, what we deal with the waste at the end of the day as well. So for today's lecture, keeping in mind the Nano&Bio projects products mindset, I want us to think about sustainability for just the purpose of this talk, or the purpose of this lecture, as sustainable materials. So sustainability involves sustainable materials that are sourced in a way that does not negatively impact the environment in the long term, so that, you know, things can recover, and that does not decrease the supply permanently. So that means basically, you know, fossil is the easiest example, because we know that we have taken way too much and it won't recover. And then now we need to find alternatives to fossil. So that's why we're looking back. One of the reasons we're looking back at the bio-based stuff. But the idea is that we do not limit or affect the future generations' access to natural resources if we're working with natural resources. They need to be able to walk on the forest, especially here in Finland, which there is forest everywhere. The same way that we do, but that they don't lose that, the well-being, the importance of that for their well-being as well. And this is adapted from, you know, the United States Environmental Protection Agency. And we also want to consider that social, environmental, and economic impacts of the entire value chain, and keep the value chain thinking in mind. Last lecture, we talked about what is a value chain, and then here I'm bringing that back. So we're talking about at least three things: the social, environmental, and economic, and that the value chain thinking. So it's not just about the process I'm developing, but where does it fit in? What product is making? What is going to be done at the end of the life with this product? Who is it affecting? For what end user am I producing that? So basically, this is what I would like us to consider, and is that like at least a very simplified way where I perceive sustainability. We should stop using this word loosely, just like mentioning it in every title of a project, just because we need to consider sustainability. So we're putting that in the title, or we're just making one little paragraph. It's sustainable because I'm using natural resources. Dot. That's it. No, it's really, it's not about that, because things need to be benchmarked, need to be compared. It's about how does this perform in a fully, entirely sustainability analysis, technical, economic, and social. I feel like I'm being very repetitive here, but I hope, because this, I was told that this is a large public, and I want to share this message to as many people as possible. And then how now we think about that at early stage, in our research, in our projects at school, at the university, or in our companies. Early stage, when we are creating something new, when we're making nanomaterials, when we are making new types of bioproducts out of these nanomaterials. This is a bit of an ugly slide, but we have talked about technical and economic. I'm really sorry we haven't touched very much the social aspects. I have some friends working very heavily on this, and this is often forgotten. But today, for the time we have, we're going to talk about environmental. So what are you addressing? Remember that first question. What is the environmental issue that your technology is trying to address? We are sometimes good at doing that. At least when we start writing papers, we start talking about that. What do you think? Where do you think that your issue, your solution is addressing that issue of, I don't know, microplastics, of, I don't know, feed, or, you know, better production of crops, or replacing fossil-based resins in the construction industry, which is huge, or, you know, making concrete, or sequestering CO2 and storing CO2 inside of the wood. There are some amazing projects on that. And then what, at least these 3 questions I want you to think. And you can think about those even if you have no idea yet of, you have no data yet, but you just start thinking about it, and maybe go to the literature, start questioning your research design. And what are the end of life possibilities? Say I'm gonna make this paper. I keep getting my post-its here. Then what can I do with this at the end of the slide? Okay, it's recyclable, we know that, but can it be separated in the current existing municipality waste collection systems? Again, perhaps I do something else about it. Maybe if we think about textile, I can take something, some textile fiber mixed with bio-based fiber, or if I make a fully new fiber from a waste stream out of the pulp and paper industry, and I can make a garment clothing out of it, then I might be able to upcycle, actually, make it an added value use of that stream. And then another very important aspect, which is very easy usually to see very early stages, is the energy intensity. Do I need to grind things? Do I need a high temperature process? Or do I require, what is the energy source that is required? Is there anywhere in the process that I can circulate the energy and optimize the energy in any way? So is it energy intensive? That's one of the issues as well, especially when you think about the environmental perspective of sustainability. But remember, sustainability not just about environmental aspects. Then this is at very early stage. Then if you are able to actually run a life cycle assessment, which is not always the case, then you might be able, one thing that I want to mention actually is, for instance, I don't know if you're going to see here, but like my coffee maker and my kettle, like that to warm the water, they are from a recycling center. So in many countries, you can go and pay 10% of the original price for things that people throw in the trash. And they just go to these recycling centers, you can buy clothing, you can buy things for your home. And this is, to some extent, things are gonna go to waste, or gonna go end up in a landfill. It's get a second life, it's used again. And we have been doing that a lot when we live in Canada, and we do that here in Finland and all over Europe. This is really, really, really they are big shopping centers just for recycled stuff. So you can put furniture all over your home, just paying 10% of the original price because someone threw it away. So this is another perspective. What can be done at the end of its life? It can be collected and securely reused somehow. Then, if we go back to our processes developing new technologies, if we can develop a life cycle assessment study, nice. But this is the most used environmental assessment tool. And why is that? Because it is well standardized. For instance, we have the ISOs. All the industry have done it for their processes. It's well backed up in regulations. So basically is accepted, and it is the method that everybody uses. However, if you go and you search, you're gonna find tons of environmental assessments out there, indicators, studies, the different frameworks and different things. But the life cycle assessment, I think, is to some extent the most robust option and the most well accepted option, and the other ones are add-ons to it that you would add if you see that case study and that it makes sense for that type of study that you are developing. And that's how we measure the environmental side of sustainability, to make it simple. So basically it helps us determine the environmental impact. And it results in various environmental indicators. It's not just about the footprint, not just about the CO2 footprint. It is about many, many other things. And if we consider the way we would run an LCA, I don't know, like if everybody here has done it, heard about it, studied it to some extent. When I have this in my class, I always ask the students, and then there are various answers, because some people just get interested and they go and they learn by themselves. But just to take the basics, so if we consider the ISO, the basic steps are, first, what is the goal? So remember in the previous lectures that we were talking about defining the product, defining the supply chain, the value chain, defining the process. That is also necessary when you are doing an LCA. So you can do all of that without doing an LCA. The LCA is going to give you the environmental output. You can do those processes to think about the economic output, the technical output, but we need to do that also here. So basically, I have an example here. So we wanna think about the boundaries. So are we thinking about cradle to grave? I would think about cradle to gate. So basically, cradle is where the material is born. So the tree is growing in the forest. To gate is the gate of the mill, for instance. And to grave is like from the forest all the way around the value chain to the end of life management. And then maybe can we even go up to reuse again. So, or you can even think about scope 1, 2, and 3. If you have more of this industry mindset. But it's very important that you define the scope, that you define maybe you're doing the LCA just for the process, just within the process, not even think about the source of the feedstock getting to the gate of the mill. Then when you consider the unity, functional unity, for instance, if we're thinking here, I have CF, but CF means carbon fiber. If you were making 1 ton of carbon fiber, that is your unit. So it's going to be, how much do I need to make 1 ton of carbon fiber? X grams, tons, whatever, of CO2 per 1 ton of carbon fiber. So that's the unit. So you define those 2 things. And then basically you do an inventory. Then you document every piece of information, mass and energy balances that we talk about, the economic analysis. But then now here, before we were thinking more about the technology and how we develop this technology and the risk, and we do some preliminary technical economics to understand what is the CapEx, what's the OpEx. Now we are talking about this energy flows, and within the system boundaries. So we might, if we are thinking about cradle to gate or cradle to grave, we need to think about the flows all the way from where the raw materials are produced all the way to the end of its life. So it's not just about the technology, the system within the system boundaries. So we document, we go, we look for it, we interview, we investigate. We basically, if you are doing this at the research level, it's very uncertain. So in lots of uncertainty analysis, in the previous lectures also, we need to always consider the importance of uncertainty and uncertainty analysis and sensitivity analysis, because we have a lots of things we don't know at early stages. And that's in inventory analysis is where you flag the things that you are most uncertain about, the things that you don't know about. And then in the impact analysis is where you actually assess, you actually evaluate, and then you look at, okay, you calculate all the things. We prefer not to use black boxes, try to open the process as much as we can, break it down, not just put things in and get things out. As much as possible to identify flexible tools to run the LCAs, not black box tools. And black box basically mean, you don't know what's happening inside of the process or inside of one step. You just assume that it is what it is in the database of that software. And then you interpret, and that is the interpretation is the most important part, because that's where you reduce uncertainty. Especially if you're doing a case study, you can only make conclusions about your case study. You cannot make conclusions about the overall sustainability of the process. It's just if you do things the way you said in that case study, in those boundaries, then this is the result. So it's very important that you keep that in mind, that you propose improvements considering the boundaries. And whenever you want to make extrapolations, then you need to extend the boundaries. We need to think of what and how would that new scenario look like, and then say, if the scenario is about A, B, C, D, then the LCA would be different. So always consider the interpretation, the critical analysis of what you're finding. And then it's an amazing tool, but it has lots of limitations, which is normal, which is expected. So for instance, I have just the example here. If we were to make polymers, so it's cradle to gate. So basically, if you look here, the dashed line indicates cradle to gate. So from the extraction of fossil fuels to the gate of the fossil plant, or the chemical plant that is going to make the polymerize and manufacture the chemicals, or the inputs to making the final product that's going to be used. So basically, this is the cradle to gate that I was talking about before. And then the dotted line, this blue one, is the extension, the system boundary that's called cradle, where things were born, to grave, when things die. So disposal, basically. But then there are also options to reuse, recycle, remanufacture, all the R's of circularity, which should also be assessed when possible, whenever possible. Otherwise, it's very difficult to compare and to see the overall, especially if you don't think about the end of the life, especially if you want to consider, what is the impact on climate change of your product, of your process, of your proposed technology, of your final material. You have to consider the end of life. There's a lot of uncertainty still for the bio-based products. How are those nanoparticles going to react in the soil after a long time? There are lots of assumptions, and I think most of them are right, but very little research done so far compared to fossil polymers. So remember, whatever results you have, they are only for your case study and for the boundaries that you have considered. This is a good and a bad thing. Then here again, we are looking at the bio-based polymers, and then here you have seen this PLA is bio-based, here polylactic acid, And the thermoplastic starch is made out of starch, is also bio-based. And then the other are the typical types of polymers from fossil resources, the gray ones. So you can see like high density polyethylene, low density polyethylene, PET, PET, garrafa PET, que a gente fala em português, polyestyrene, polypropylene. So basically, this is one thing, right? Here you're showing carbon CO2 equivalent, which is the thing that we see everywhere, which is used for a lot of things, which is a great indicator, and that for some people is, for them, LCA's life cycle assessments result in footprint. Some people now are talking about the handprint, but we're not going to get there, but it's another topic to discuss. But it's about the measure of global warming potential. I just want to say that this is limited. This is only one thing, which might not be the most important thing for sustainability, because there are many other things that a life cycle assessment can tell you that the CO2 equivalent is not going to tell you. It's a good benchmark to compare things. I really recommend this paper, by the way. It's old, but it's a nice one. That the other things that sometimes about acidification, ozone depletion, human health issues, especially depending on the application. Remember in the market analysis, we talked about the types of products. Here at the beginning, I talked about what is the sustainability issue you're resolving. The sustainability issue you're resolving can be about the pollution that a plant is causing in the local community. So maybe you want to look more at these human health issues more than the CO2 part, because these in that example are more important. So it's really, really about that. We need to think about the local conditions. If you have a black box where you don't have any way of knowing what's happening in that process, what are types of, especially the types of VOCs or types of the pollutants that are coming out of the fume hood out of the process. If you don't know, if you have a black box that doesn't tell you about that, how things are reacting, then you cannot make conclusions about this. And then sometimes these are very much misleading estimations. So for instance, if you have a mill, that's a very practical example. If you have a mill close to the city, and then the impact of whatever is coming out of that mill in the air and the air quality, if that city is heavily populated and it's concentrated around the mill, then that's one of the most important things to look at. If this mill is located, isolated, further away, where there is a lot of land and things and open air for those things to go out in the air and not go down and interact with the low level air that we breathe, that it can also, we would react and not be as harmful as it would be in a concentrated local climate type of issues, because the local considerations play a role, especially on the social and environmental health of humans. So think about those things as well that sometimes we don't think about today. I wanted to bring this up here as well. The LTA is not just about CO2 equivalent. Then I want to use us to think about sustainability. Now that we have talked about environmental, we have talked about the technical parts, and now a little bit about the environmental, but previously about the economic. Now I want us to think of this engineer's perspective. All of them have social before anything else. All of them should be socially centric, because we're making things for people. We are supporting the development goals. So you should consider to be able to speed bioproduct development or Nano&Bio projects, sustainability and success in the long term. We need to think about the technical. So can we achieve this performance? Can we make the product that the plant is going to absorb? Yes. Or can we make the product that's going to be biodegradable? Yes. Can we make a product that's going to be water resistant? Yes. Or, depending on the application, there is a list of technical specifications and regulations even about those technical specifications. Then how is it going to compete? is it going to be price-wide competitive? Like this morning, I was in this amazing lecture about algae capturing CO2. It was just like fantastic, but the cost was absurd, and they were actually coming up with ways of reducing that cost and recyclability, and especially the downstream costs. But I mean, in the long term, this is amazing. And the environmental part of it is where we could achieve below net zero. So there are different levels that each solution is going to perform in each one of these three bubbles. And then is about trade-offs. It is about decision-making. It is about, what is the most important at the moment. And where can we compromise on our projects? So, and the last thing I want to emphasize on this slide is that if we're using renewable resources, if we're using forests, if we're using whatever captures carbon, we should be thinking about how do we achieve below net zero. Just being net zero, I think it's not enough for the conditions we have right now. So let's think about how could we achieve below net zero with our solutions. So this is the engineer's perspective, and the last part of the presentation, just for the next maybe 5-7 minutes, is about how do we take these things that we've been talking about in the last 2 lectures, risks and sustainability, from this value chain perspective, because like LCAs are about being able to cover the whole life cycle of a product. And when we do techno-economics, we should think about the value chain, the product. When we think about the technical specifications, we need to think about also what the end user needs. So all of them involves this value chain perspective. And so, but what is this value chain for the bioeconomy? So I'm just taking this figure that my postdoc supervisor and I designed some time ago, and think about, we have the agricultural crops growing, we have the different forests, either planted or natural managed forests. So we harvest it, we bring it to the mill, and then we transform it into pulp, we transform it into biofuels, we transform it into nanomaterials, we transform it into something, sometimes just one process, sometimes there is a secondary transformation, we need to do one more process, sometimes we go all the way to make the final product. So in the same mill we make the paper, we just not only make the pulp, and then we transport it to distribution centers that end up going through to the consumer. Then once we drink our coffee in a non-reusable coffee cup, depending on the type of coffee cup, if you look at the commercial that I shared with you, the last part of the commercial, they stop the car and they ask the person, are you drinking from a foam cup? Foam it's like this type of foam, it cannot be recycled, nothing can be done with it. And for a very long time, especially in 2010, when the commercial was made, the cups in these lots of coffee shops in North America were made out of this styrofoam, this terrible foam that there is not much can be done with it at the end of its life. So that's why, like, the green police was really mad at the people drinking that type of cup. So we really need to think about the whole value chain and how does that, what can we do at the end of the life? Now, one example, and I was a bit lazy here, and I didn't change my example. I just used the case studies that I have worked in the past. I didn't change to nano, but kept the bio. So here in Finland and in many places around the world, we are looking at bio-based textiles from cellulose. So when we look at this value chain perspective that I showed you before, we can consider, are we making this new textile from natural managed forests, like in Finland and Canada, or are we making from plantations, or are we making from residues? That's going to impact the overall sustainability. We can think about what are the impacts in the local, regional, and international logistics. Are we bringing the feedstock, the pulp, all the way from Brazil to Finland, which is some cases is like that? Are we making it locally? Are we making directly from pulp, or are we modifying the pulp? Are we making microfibrillated cellulose, MFCs, microfibrillated cellulose? How complex is the technology versus how much more value I can get out of the pulp? Who am I collaborating with? Am I making this on my own? I'm making just the yarn, like just the line, like the textile fiber, or am I making the whole garment, the clothing? Who am I collaborating with? Who are, you know, the big guys here, the automated market pull firms, the firms that are close to us? So I don't know, like H&M, Hudson's Bay, we think about one in Brazil, Renner, in Brazil. So who are these guys here that I'm collaborating with? Do I know them? Am I even collaborating with? What do they do? What are their claims? And can I make it and sell to larger markets, or making something very fancy and expensive that is very unlikely to reach the average consumer? And then what in the life, we really don't know much about this. Are we mixing synthetic and bio-based fibers? Are we making fully bio-based? I don't think we want a biodegradable clothing to some extent, depending on how you define biodegradable, because it's going to not last very long. And usually when things don't last very long, the environmental footprint is not as good. However, if we make it fully bio-based, are we able to recycle? How many times compared to synthetic? All of those things need to be taught early on research. So the whole point of my pitch, kind of, and the research, what my research group does, and I'm closing this lecture by saying that as a new professor, I'm hiring lots of students, there are 4 PhD positions, 2 which I just closed, unfortunately, before, but I had 150 applicants, so I'm pretty happy about it. But there will be more positions coming as well. I'm building the team here. And what's the team going to do? We will improve the science feedback loop. We are going to take this value chain approach, taking a sustainability from an engineering perspective, and we are going to improve this loop. So we have an idea in the lab, we work on it, and then remember about the technology readiness levels we had in the first lecture. Now we do some process design, we think about the block flow diagram, we do some process simulations, and then we see like, okay, we can make some material, we can make a prototype out of it, maybe just 1 kilo, 2 kilos, something small, depending on what product we are talking about. And then, doesn't work. We need to target another application, go back to the lab, but do this as much as we can, because remember, I mentioned the first lecture, we had a lot of freedom of design when we are early stage. As we build things larger, we lose the freedom of design and things cost more. And we don't want to build something huge and then let it not succeed, because that's a loss and a lot of time and money lost in there. So the idea is that we interact a lot here, that we take sustainability into consideration from its full perspective, and that we improve the innovations that leave the lab. Just to close with the next 30 seconds, this is the idea of this interdisciplinary approach. Is the idea that we create this translation framework for sustainable bioproducts innovation to make it a big name, is that we do life cycle assessments, we do technical-economic analysis, or look at the circularity of the business models, which we did not have time to discuss today. And then we go back to the lab and we develop pre-pilot and pilot, and we work with industry, we work with end users, we work with people that are closer to other people that are going to actually use the materials, products, the nanomaterials we develop, so that we can create these key performance indicators to feed this framework in a very robust and diverse way, where we can really look at how do we de-risk, how do we develop, how do we accelerate the development, and we get more innovations out of the lab. So this is what my research group is developing here at Aalto in Finland. And I'm really happy to have contributed to this event, and I hope you enjoy these lectures. If you have any questions, there is a little session for questions after the webinar, and but feel free to reach out to me. And I hope you have enjoyed. I enjoyed sharing a little bit with you, and I look forward for the live questions during the event. Bye now.